In section 6, we're going to do some more work, but now on percentages and mixture problems. And I do suggest that you write these out on the left side of your paper so that later you can come back and do these. Now, as we read these statements, we want to convert them into an equation. And often they can be directly translated from this into an equation. So let's do letter A. 5%. The word of. Of in mathematics often indicates multiplication, so we'll put it in parentheses to indicate multiplication. Is an equal sign, and then what number? N we can use. So there's an equation. We just multiply this, and that comes out to be 15. So I've done these already with my calculator, and that's the answer. Now for letter B, 207 is equal sign 90%. Need to convert it into a decimal of what number? I could put parentheses, but since it's a letter, I don't need to. Now, how do I find out what n is? I'm going to divide out the 0.9 and I get n equals 230. So knowing the process, converting the statement to an equation. In other courses, when students would do this just on paper, I would need to see the equation for them to get full credit. That's what we're working on here. Letter C. 15 is 1% of what number? Well, here we're going to divide both sides by 0.01. We want to isolate the n. And we get n equals 1500. And you just use your calculator for this. Now, what percent? So we can use P for percent here of 350. Remember, of is multiplication, is 420. Now, how do we get the P by itself? We divide out the 350. Now, when we do that, we get P equals 1.2. Now, that is not a percent here. How do I convert that to a percent? Well, the rule is move the decimal place over 2 places and add a percent sign. Now this is the answer. So that might have been a little tricky for you. you got percent as a regular number, in this case a decimal, you had to convert that to percent. Okay. Some of these can be done by arithmetic, but we'll set it up in algebra a little bit by using some letters. Here we have a sales price, and there's going to be a 75% discount of the original price. So 75% of the original price gives you the discount, which will be $97.50. Then you take this discount, subtract it from 130, and you get the sales price as $32.50. And that is quite a savings. And basically you're going to take 75% of this, subtract it for this. Now another way of figuring out what this would be, if you're getting a 75% discount at the register, you're only paying 25% of this. So this is actually 25%, this is 75%, and that adds up to the 130. All right, let's look at letter B. Anniversary dinner costs this, excluding the tax. Find the total cost if a 15% tip is added to the cost. Well, you could take 15% of this and then add it to this. Or another way of doing it is you're going to take 100 and 15% that I'm converting to a decimal of 145.23. So there, the 1 is 100%. This is 15%. So you're paying 115% of this, and that gives you 167.01. So they want you to round to the nearest cent. I probably would drop that, but again, follow the directions, because if you don't, they're going to count it wrong. But again, I can give you lots of partial credit for something like this. Let's go on. Now, for number 3, we need a little bit of background, because here we're talking about percent of increase and percent of decrease. And we'll use this as an example. So the number of minutes on a cell phone bill went from 1,200 to 1,600. So what kind of problem would this be? Increase or decrease? Well, it's obvious it's an increase. But they're all treated this way. We're going to subtract to find the difference. So 1,600 minus 1,200 gives us 400. Now the rule is you put the difference, which is 400, over the original amount, which is 1,200. Now we can just cancel these out, and this is 1/3. But again, they want to know the percent. So what is 1/3 as a percent? Well, to make it exactly. This is 0.33, and the 3's continue. So in a sense, this is like 1/3. We now move our decimal place over, and this becomes 33. And if we're rounding to the nearest whole percent, that would be it. And I believe that's what they want. Let me look it up a little bit here. Yes. Okay, letter B. Here in this year of a college campus, they had this many students. But the next year, the enrollment went to this. So this is what they had originally. This is what they had the next year. So enrollment went down. This would be a decrease. So we do 8900, 7600, and we find the difference of that is 1300. Now you take the difference, and again, what number do you put it over? The new number or the original number? And again, the rule is always over the original number. And when we do that, we get 14.6. Well, actually, it comes out with our decimal here, that we then move it to a percent. Now, they want to round to the nearest whole percent now. So if you put this in MATLAB, they're going to count it wrong, because they asked you to do this. Now, I would give you, lots of partial credit for this. You're just making an error in rounding off. But here, if it's 5 or more, we drop this and add 1. So the answer for this is 15%, and that would be decrease. So basically the formula is the same. Find the difference, put the difference over the original, and then convert to a percent following the instructions that they're giving you. In letter C, after reading this is the original price. If the sales price is this after a 20% discount. Some students think they can do this just by common sense, and where they may get close to the answer, it's incorrect. So I strongly advise you to watch this and then use this as a model of how to figure things out. So we have the sales price, and we want to develop an equation or an expression on this side that will equal this. Now, do we know the original price? And the answer is no. So we're going to call that P, the original price. You can choose any letter. Now, something happens to that original price so that eventually it becomes this. And what happened to the original price? Well, there was a 20% discount. So what percent then of the original price is this? Now this isn't 20%. Think about it for a moment. This is 80%. And that's the key. So 80% of the original price is the sales price. This is 80%. So they're giving you this hint, but often what students do, I won't say what they do, but that's wrong. Think of it as 80% of the original price is this. So now, how do you find the answer? We'll just divide both sides by 80, and we get the original price is 150. And again, I strongly urge you to study this, see if you can understand what's going on. Now, in the last example, this is of a mixture problem. So how much pure acid should be mixed with 4 gallons of 30% acid in order to produce an 80% acid solution? And they're suggesting you use a chart. So how much pure acid should you use? We don't know. So we're going to call that, let's say, N. Could use X as well. Now here's key. What is the percent of pure acid? Well, it's 100%. That if we convert it to a decimal, is this. Now this is critical. You'll see why here shortly. Now, we're going to mix it with 30% acid solution. How much 30% do we have? Well, we have 4 gallons, and that is 30%. Now, when we finish, how much will we end up with? Well, we're going to have the N amount, which is unknown, plus the 4. And what strength will this be? Well, it's going to be 80%. Now, we can just do this multiplication, and here's where students mess up a little bit by failing to do this, which is really just 1N, but put that there, you'll see why. And then 30% of 4, and this will be 80% of N plus 4. And we have to put that in a parenthesis. So what will our equation be? Well, we'll write it up here where we have a little more room. 1.00N. This is our unknown amount of pure acid plus 30% of 4 equals our N solution, which is 80% of N plus 4. Now this is the beauty of algebra, that you didn't know this, and you could keep mixing things and trying, but by using the algebra, it tells you just how much you're going to need. So what would you do first here? Get rid of the decimals by multiplying every term by 100. And now we get 100N plus 120 equals 80N plus 320. That doesn't look too hard. Now we're going to transpose this and get 20n here. We're going to transpose this and get 200 there, subtracting this from both sides. Then we divide both sides by 20, and we get n is 10. So we will need 10 gallons, or that's correct, 10 gallons of pure acid mixed with 4 gallons of 30% acid to give us an 80% solution. And we'll have altogether 14. They're not asking us that. So many of these are related. They sometimes have little modifications. A chart is good. We'll see that a little bit in our next lesson.